Today we're going to be looking at factoring our trinomials when our a term is greater than 1. Remember, we're dealing with our standard form is ax squared plus bx plus c. And our a term, the term in front of the x squared, is going to be greater than 1 for all of these. There are a couple of different methods. Our first one we're going to look at is I'm going to do what I call multiplying ac and adding to get b. So we multiply and then we have to add. So I'm going to multiply 5 times 6, and 5 times 6 gives me 30. And b, in this case, is a negative 17. So I have to figure out what can I multiply to get 30, but add to get a negative 17. Since my 30 is positive and my 17 is negative, I know that both of my numbers have to be negative factors. So I don't concern myself with the positive factors, only the negative ones. So I have negative 1 times negative 30. I have negative 2 times negative 15. Negative 3 times negative 10. Negative 5 times negative 6. And I look at these pairs and say, which one adds up to get negative 17? Well, that would be this one right here, negative 2 plus negative 15. So now what I'm going to do is I'm going to go back and rewrite my middle term here using my negative 2 and my negative 15. My 5x is not going to change. I have 5x squared. Instead of minus 17x, it's going to be split into two pieces now, a minus 2x and a minus 15. And then my plus 6 just comes down the right. And now I'm going to do factoring by grouping, looking at my first two right here. What is my GCF for the first two? This is only going to be x. So I'm going to take x out. And in doing so, it leaves me with 5x minus 2. I now do some grouping with my second group here. And my goal is to make sure that what's left over after I take my GCF out matches what's in the parentheses after my first section. So I'm going to take out here a negative 3. So that makes a positive 5x and a minus 2. So now these two pieces are the same. Since those two pieces are the same, I can now take them out, 5x minus 2. And when I do that, they have come out. I'm left with x minus 3. And that is our factored form here. I was looking at example 2. Now with example 2, we're going to do similar process as we did in example 1, where I'm going to multiply my a and my c together. So I'm going to do my 3 times my 7, which will be 21. And I'm going to rewrite my problem as x squared plus 20x minus 21. And at this point, I can treat this just as we do ones where my a is 1, because in this case, a is 1. So I'm going to say, hey, what could I multiply to get a negative 21, but add to get a positive 20? So I have to have a negative number, so that means I have to have one of each. So if I have a negative 1 times 21, that gives me negative 21. Negative 3 times a positive 7, that gives me negative 21. What if I have a positive 3 times a negative 7, or a positive 1 times a negative 21? Which of these pairs can I add together to get a positive 20? This one here, negative 1 plus 21, that would give me 20. Since my leading coefficient is 1, I can automatically drop straight in x minus 1, x plus 21. But remember, my original one here was 3. So I have to now go back and divide each of these things by 3. Well, 1 I can't divide by 3, so if I can't, this one moves to the front. So this becomes 3x minus 1. Here, I can divide 21 by 3, so I now have x plus 21 divided by 3 is 7. And now it has been factored. Okay, well, moving on, looking at example 3, we're going to do the same process we just did in example 2, where I'm going to multiply my a and my c. And rewrite my problem, so it's going to become x squared plus 12x plus 20. And here I've got to go then and say, hey, what can I multiply to get 20 and add to get 12? Well, let's think about my factors of 20. Since I have positive and all positive, so I'm only going to consider the positive factors. So I have 1 times 20, I have 2 times 10, and 4 times 5. This one right here in the middle, 2 plus 10, that gives me 12. So over here then, I'm going to rewrite this as x plus 2 times x plus 10. But remember, I originally started with a 4 here, so I have to go back and put a 4 underneath each of these. Now 4 does not go into either one of these evenly, but I can reduce my fractions, so I can reduce these things so they become x plus 1/2 and x plus 5/2. Now my denominator gets moved to the front on each of these. So my final answer would be 2x plus 1, 2x plus 5. And there's the factored form of 4x squared plus 12x plus 5. Now looking at example 4, with example 4 we're going to go back and do our grouping method like we did in example 1. So I'm going to go through and do my AC and my B. My AC, that's 3 times 4, so that's 12. And my B in this case is negative 7. So what can I multiply to get a positive 12 and add to get a negative 7? So again, I'm only going to consider my negative factors. So I got a negative 1 times a negative 12. I got a negative 2 times a negative 6. And negative 3 times a negative 4. Oh, look, winner chicken dinner. We got it right there. Negative 3 plus a negative 4. So I'm going to come over here and rewrite this problem as 3x squared minus 3x minus 4x. So remember, we're separating this out into 2 separate pieces. And then my plus 4 comes down for the ride. I now do my grouping. The first two, I can take a 3x out of both of them. So I take 3x out, which leaves me with x minus 1. With these two right here, I can take out a negative 4, which leaves me with x minus 1. I now have an x minus 1 in common with both of these pieces. So I now have x minus 1. Those have come out. I am then left with 3x minus 4. And you're done. So 2 different ways of factoring trinomials when our a is greater than 1.